Okay.
Oh, jeez.
I'm getting I think you're sharing the other screen though, if you have a dual monitor thing.
Yeah. What are you seeing on your end? Are you seeing the presentation or no? Why did the audio drop out? Oh my goodness. The Zoom page says it's sharing the presentation.
It's sharing, but I think literally this, like the share is frozen.
Oh, good.
Yeah.
That's not helpful. Let's try restarting it.
Okay. I can see it.
Awesome.
I'm gonna hope that it doesn't freeze.
Let me know if there's more issues.
Okay, cool. So awesome. Glad you're on. We have about 30 minutes, so I don't know how much time this presentation is going to take. So I guess if we want to like speed run the introduction and everything, I think I've introduced you a little bit to everyone, just mentioning that you had like past history as like the president of AES, but yeah, I don't know if you want to elaborate on that a little bit.
Real quick, I grew up in the Bay Area, did community college for 3 years, and then did Cal Poly for the next 3 years. And my major was general engineering, which consisted mostly of EE classes, because there's that giant chain to get up to DSP, and also music tech. And then I also did a physics minor on top of that. Most of my audio background is in theater. I did a little bit of live concert work, setting up shows, tearing them down, all of that. And did the internship at Harman at Northbridge, just the summer before my final year. And through that, I was able to get a position at Harman Novi in Michigan. For this presentation, we're just going to go through the company really quick and then go through the basics of what we keep in mind for the tunings, and then the actual process we go through, and then features that we tune on top of that. So the company did some restructuring earlier this year. It's split into 2 divisions between automotive and lifestyle. Automotive is all of the technology that's in the vehicle in addition to the tuning. Lifestyle is your consumer products, the pro products, all of the speakers, headphones, and all of that. And the other change Harman went through was to move from a technology-centered view to a experience and human-centric view. So instead of listing all of these products we have, our goal is how much does the listener enjoy them? How comfortable are their lives? And part of that is to make everything connected, your car, your home, all of it, and to do augmented reality stuff to incorporate it even further. And for specifically car audio, these are the 9 brands that we work with. I've mostly worked with JBL. I did a little bit Bang & Olufsen and a slight smidge of Infinity. And Harman as a company is located all over the globe, and automotive alone is in the US, Japan, Korea, Germany, probably some others that I'm missing. And for the acoustic engineer role, our responsibilities can include designing the system, so speaker count, speaker placement, defining an acoustic spec, what targets do we want to reach, how are we measuring those, packaging, so the enclosure, how it's actually being put into the vehicle, the signal flow design, so that we have all of the filters, gains, delay, everything that we need to tune the vehicle. And also amplifier and software integration. So does the system connect the way it should? Is everything integrated? Does it pass audio? We sometimes do some customer prototype demos to showcase for what we're capable of, trying to win new businesses. And then of course the vehicle tuning that we're going to go through in a bit. As far as tuning basics, sorry, you're good. These are a couple sample architectures of what a system might look like. The left one has 13 speakers, the right one has 25. So unities count as 2 speakers. So you can see the difference between them. Usually the main differences is, do we have a woofer tweeter in the front, or do we have a woofer mid-range and tweeter? It's one of the most common differences. And in addition to being located in different places around the vehicle, they can also be located at different heights in the vehicle. The system on the left has 19 speakers. The speaker on the right has 36, which is insane. And I'm very glad that's not my responsibility. So spectral, we want the frequency response to sound even. We want there to be a level of quality across the entire frequency spectrum. We found through our work that amplifying the bass and bringing the treble down is how we get to that goal. But overall, you just want things to be clear. You want to be able to hear everything in the track without any distortion or muffling or anything like that. And part of that comes from the Robinson-Datsun curves, which you might have seen before. It's just that we don't hear frequencies evenly across the spectrum, which is why we don't tune for a flat vehicle, while you have the curve that you saw earlier. We also focused a lot on spatial. So we want the vocals to be centered in the vehicle, the left and right edges of the stage to be as wide as possible. And we want it to feel like there's an openness to the sound, which is very subjective and not easy to describe without an example. We also want the stage to be very stable. So listeners of all different heights, different positions, different backgrounds should more or less agree on what they're hearing, which is what you see in this example, except for whoever thought the center vocal was massive. And alternatively, we have poor alignment. So a scattering of locations can either mean that every listener is hearing things in different places, or that they just don't know, so they're sort of approximating. And that's why you see things all over the map. And the top one as well, that system had speakers only in the rooftop, so the stage felt that goes over your head because there's no other source of audio. And then the bottom, the stage is at a good height, which basically just means that it's directly in front of you, but the points are still very scattered. The other thing that this kind of shows is that we want the stage to be at a good depth from the listener. So it's not like in your face, but it's also not like out on the hood, which I haven't actually heard before. We want it to be pretty much on the dash, like behind the steering wheel. Oh, also the bottom one has a bit of a split vocal image. You can see 2 clusters of blue, which also indicates that there is poor alignment in the system. Time alignment is one of the biggest factors that we have to deal with because the speakers are asymmetrical from you, and you also have a list of speaker pairs. So you need to align them so that they all reach you at roughly the same time. So for example, if you have a speaker a foot away from you and you have another speaker 2 inches away from you, you want to delay the closer speaker by 0.74 milliseconds so that the speaker a foot away has time to reach you. And we get that arrival time from an impulse response measurement, and we just measure where the first peak or dip in that response is, and we use that as our coincident. The time alignment also leads to phase issues. So if you have 2 sources symmetrically away from you, their sound waves are going to theoretically be constructive because they're arriving at the same time. But since our speakers are all around the vehicle, they're at different angles, we get destructive interference as well. So we have to manipulate the frequency response to have as much constructive interference as possible and to fill in the gaps where that destructive interference is still present. And of course, we're also not dealing with just a sine wave, we're dealing with the entire frequency spectrum. So even just 2 speakers can align on a section of frequencies, but not be aligned in another section of frequencies. The differences between tuning a room and tuning a car are a lot. So with a room, you can have just 2 sources. With a car, you usually have a minimum of 4 and up to 36. A room has 6 main surfaces, not counting any treatment you might be doing. A car has God knows how many surfaces. A room is mostly perpendicular. The car has all sorts of angles, both in the speaker and in the surfaces. A room is generally symmetric, and a car is symmetric in the speakers, but the space will never be entirely symmetric. At a minimum, the steering wheel is getting in the way, but also cars are themselves. The dash isn't always symmetrical. The rest of it is decently symmetrical. In a room, you can place yourself in the center of the whole system. In a car, you're always off center. And a room is acoustically isolated, more or less. A car has road noise, tire noise, wind noise. The room is also generally sturdier, whereas a car has buzzes, rattles, resonances in the vehicle, things like trim, and also sometimes the packaging is not the best quality if we have a cost restraint. The tuning process that I go through, we're going to use a 5-channel system for simplicity's sake. So in this example, there would be 2 speakers in the front, 2 speakers in the rear, and a sub somewhere in the vehicle. And we start by measuring all of the speakers. We flatten the speakers to have a clear frequency response, and then we align all of the speakers to each other. And then add global filters to do the bass boost and the treble attenuation that you saw earlier, and then adjusting the overall gain so that we meet the SPL target. So going through that in more detail, we have initial measurements of all of our speakers, all of our channels rather, and this is taken with no EQ, no crossovers, so we see how the speakers are reacting to the cabin that they're in. And then we take each of those channels, flatten them out to get rid of any peaks or dips that are messing with it. And for this, we are going for a flat. So we are working with we don't want to introduce more variables by introducing the bass boost and treble attenuation here. That might change how the speakers interact with each other. So we're using a flat response to get the clearest picture of what we're working with. We then take each speaker pair, so either your 2 front woofers or your rear pair of speakers, and see how they play with each other. So in the top, you can see that there's cancellation around 500 or so hertz. And we're going to manipulate the response so that we get constructive instead. And we also have to listen to that and make sure it's actually sounding good, because a graph can look pretty perfect while sounding terrible from an uneven phase issue on either side of your head. And then once we have all of that completed, so you can see each pair of channels in the sub are, oops, my bad, wrong slide. We take speaker measurements in the first row and the second row. And we tune most of the vehicle from the front row, but the second row is what we use to flatten out the rear speakers, because those speakers act very differently between the rear and the front. You can see the main difference that you can see with this system is that the rear speakers are louder in the rear, but sometimes there's a large difference in the frequency response as well. So we'll flatten out the speakers in the rear and then go back to the front to time align them and work with the phase issues. So from the start to a first pass at tuning it, we have all of the responses flattened. We have them crossed over where we need to protect the speakers. And then we also adjusted the gains. So you can see most of the rear pair has been dropped down so that it's not overpowering anything else. And then once we have all of that done, now we're looking at what the full system is doing. So are each of the pairs aligned to each other? Is anything obnoxiously loud when it shouldn't be? And we have a target that we have internally that we're aiming for, but we also need to be switching between the measurements and what we're hearing to make sure that both of those are good. And then once we're wrapped up there, we Want to make sure we're hitting SVL targets as well as what each brand is supposed to sound like. And then we have additional features on top of the tuning. So we're not just doing audio, we're also doing tone controls, surround modes, and a whole list of things that we're going to go through in a bit more detail. Starting with surround modes, we have Logic 7, which is a pretty basic stereo surround switch. Quantum Logic Surround is your 2D surround, which has more of an algorithm behind it in how the channels are distributed. And then Quantum Logic Immersion, it adds height speakers, so you have a 3-dimensional surround also above you, in addition to the 2D surround. We have something called Bassonic, which is available in some vehicles instead of tone controls. Instead of your bass, mid, treble EQ, you have bright, energetic, relaxed, and warm, which ties back to what's going on in the frequency response, but it's a little more intuitive and a little more feeling-spaced for the general consumer. And that has preset modes of lounge, neutral, party, podcast. Clarify is what we use to counteract how compressed music files can be. And it analyzes the track and adds back in the lost content so that you get a better quality of sound. Virtual venues is our pretty much exactly what it sounds like. It is created by taking a frequency response of a venue and then replicating that in a vehicle. Virtual venues itself does this as a static process, so it's just looking at the audio and adjusting it from there. Virtual venues live is a more robust version that also takes in information from microphones in the vehicle, so it can adjust in real time with you. We have automatic level adjustment for different sound sources. So if there's a gain difference between AM, FM, Bluetooth, or USB, or anything else you have in there, we account for that. We have an option for front passenger volume, so the driver and the passenger can adjust the gain of their specific seats individually. If the passenger wants things quieter, they can do that. And it won't affect the driver next to them. In-car communication is for people talking from the front seat to the rear seat or vice versa. The voice is captured by a microphone and played to the other section so that it's easier to talk to each other. You're not yelling over the music. Personalized phone call routes a phone call to the headrest speakers, and it allows you to take a phone call without stopping the music and experience of anyone else in the vehicle. We have speed-dependent volume compensation with 2 versions. One is a straight speed gain, so all it's looking at is how fast the car is going and adjusting the volume based on that. Vehicle noise cancellation also takes input from HVAC and mics in the cabin and analyzing things in real time and adjusting accordingly. And I think that is it. And that was very fast, but let me know if you have questions or if you want to go back and go through something again.
Yeah, thanks. I was actually curious, could you go back to the slide on the spatial stuff? There was like the heat maps.
This one or the next one?
Yeah, I guess that first one, because I was paying attention to the second one, and then I was like, oh wait, how did that compare to the first one? So
yeah,
yeah, I was wondering, for these like measurements, how do you capture that throughout the entire car? Like, do you have to move a microphone around like the entire interior and then like do sweeps at like every point, or like how do you create a heat map for the car? Especially because like a microphone, I usually think of being directional to some extent. So then it's like, yeah, how do you do that?
So this heat map is created from listener feedback. We have a benchmarking process internally that we send vehicles through, and listeners will evaluate the spatial, spectral, also dynamics and build quality of the vehicle. So this is people inputting where they hear the edges of the stage and the vocal image. The microphones are we're sort of adjusting how we do things. We've been placing a microphone both in the driver passenger and then averaging those out so that we can see what the system is doing in the middle of the vehicle, and that allows us to not prioritize the driver over the passenger. So we want both of them to have a good experience. Those measurements are all done with pink noise and is more of that frequency response. And then while we're tuning, we'll switch between taking the measurements and listening and go back and forth with that. Does that make sense?
Yeah, that does. Thanks. You're probably gonna have to speak up a little bit.
So, in terms of like consumers and like buying cars, so when you're doing like the tuning process and all this, are you like performing it in a vehicle and then like performing all the tests in the vehicle where you think the speakers should already be placed, and then those speakers are like go in that car, and then like how does that process work? Because if you just put speakers in different cars, then one will sound different in all those different places.
Mm-hmm. So we have, depending on the customer, we have some say in where the speakers are placed and where they're angled and all of that. So that's part of the development process. And then they send us a vehicle to tune. So either that's a prototype or something that's a design level or production intent, where you like to be involved with the whole process as the car is being built. And so we finalize the tuning on the production intent vehicle, and then that is the tuning for that car. And we have to do a different tuning for every different model of car for every different customer.
So is basically then every car, like even low-end cars, are those kind of customized? Are their speakers also kind of customized in like almost every vehicle you buy, or are there like general purpose speakers where, you know, if it's a, you know, a Prius or something and it's not customized audio or something, they just slap speakers in there and haven't really done a lot of testing?
There is an aftermarket product, some of which we sell, some of other brands out there. Those speakers can just drop in and replace whatever your car came with. For the branded audio systems, we're very specific about where the speakers are and which speakers those are. Unbranded, I'm not 100% sure on, but I know we also do some amount of tuning on those. So all of our Harman products are going to be tuned individually. I don't know what, say, Bose, for example, does in their vehicles, but we're usually pretty specific about how a car sounds.
So piggybacking on that, is like the tuning process and everything that you're kind of doing, because like typically I think when I think of like Harman or some sort of like speaker company, I don't think of like the tuning process. I'm thinking more of like, oh, they build like the speakers and stuff. Mm-hmm. So the whole like supporting the manufacturers of these cars to like make it sound better and everything, is that a service that they like pay for, or is it something that Harman just does because you kind of care about like what the speakers that you're producing sound like in a particular vehicle?
To my understanding, it's a very partnership kind of dynamic. So they're purchasing our product because they want a certain kind of quality to their car, and we are providing that service for them while also working with their constraints of how they build the vehicle while still holding ourselves to our quality standard.
Okay. I had one other question in terms of the in-car communication stuff. Like a lot of these enhancements that happen, are they perceptible, or is it like, can you tell that that someone's voice is being amplified, or does it sound like their voice?
I haven't personally listened to those features. But it's a feature that our customer will, what's the word? Like, it's a selling point of the vehicle to have those additional features. And I know the in-car communication front to back is very perceptible. So you will hear whoever's talking and coming out of the speakers next to you. What else was there? The automatic level adjustment, I don't know how perceptible that is. The idea is that all of their sources are going to sound pretty equal to each other. Front passenger volume should be very perceptible. Personalized phone call, I think that's just for the driver, but I could be wrong. So they're going to notice that they're hearing the phone call next to their head instead of coming out of the entire car. And speed dependent volume compensation is harder to perceive, but you'll notice when you're not adjusting the volume as you go onto the highway and that kind of thing.
Yeah, because what's interesting is, like, I know, for example, we did like a tour of the pack a while ago. Like this was like 2 years ago or something. But they have like this reverb kind of system in place where it's a bunch of like microphones kind of placed throughout the building. And they can add on like all of these like different kinds of reverb to the sound that's being produced, but you don't perceive it as being like an added kind of thing. It just sounds like, because I guess like because the ears are kind of poor at detecting a lot of these sorts of changes. So yeah, I was wondering if it kind of like just, if it's all like time aligned and everything, then maybe it just sounds like the person is just talking a little louder, or like their voice is bouncing off the car into your general direction.
I think they're pretty localized effects. We're pushing a lot for individual passengers to all be having a good experience and also a very personalized experience.
Okay, yeah. And then for the effects that you're doing, like the filtering and like adding in surround, those things, are there like separate programs you use for that, or are you having to like code anything, or like how is that done?
So integrating it is up to our software team in terms of how that's actually accomplished. As far as we're concerned, all of our features are in the amplifier, and we have a tuning tool that accesses those. And so we tune from a easy to read user interface where we're adjusting settings. The actual coding and stuff is a different team.
Gotcha. Cool.
Yeah. So when you were talking about arriving the sound in every location in the car at, from each speaker at the same time or whatever, and so like you delay, if you're sitting in the passenger seat, then you delay the left speaker or whatever, so that the right one, arrives at the same time or whatever. So how does that work then for, or sorry, that was the driver's seat. But how does that work if you're sitting elsewhere in the car? Because if you delay the left speaker, then won't that affect the other locations?
Yeah, we generally keep each speaker pairs at a symmetrical time arrival so that they're arriving in the center of the vehicle at the same time, which gives both the left and right seats a decent experience. The delays more come into play where we're aligning the front to the rear, and we're doing that so it's coincident for the front row. So our priority is always the driver's seat. Our second priority is the front row. Our third priority is the second row. So we're making compromises throughout the entire process so that everyone has a decent experience. But there are things that we can't account for. So not every single seat is going to have the exact same perfect experience, unfortunately. I did have one system where I put the coincident point not in the middle of the vehicle, but halfway between the drivers in the middle, because that's what worked better for that particular vehicle. and we're doing those kinds of things all the time as well. There's no standard one-size-fits-all tuning process that we can just reference and go through.
Well, cool. I think we're basically up on time. But this has been really cool. I didn't actually know really anything about the tuning process or anything car audio related. So yeah, thank you for kind of like providing this kind of glimpse into this as like a possibility for applying education into audio. I was curious, can people reach out to you if they have any like further questions or anything like that?
Yeah, absolutely. I'm more likely to catch things sent to my work email rather than my personal.
Gotcha. All right. Well, awesome. Thank you very much, Anna.
Yeah.
All right. Have a great day.
You too. Bye.